Well, in about 45 minutes, you're going to see me jumping through my skin because this thing is extremely loud. So let's get started. Okay, hi, my name is Tomo. I work at Wix, well, have been working at Wix for the last 3 weeks, give or take. Before that, I used to work at a different company, a different startup called New Brand Analytics, and that's what I'm going to be telling you about mostly. I think I'll head to the other side of the TV, a bit more comfortable that way. What I'm here to tell you is basically about our experiences at New Brand with Scala, why we decided to move to Scala, how we did it, like how we migrated from Java to Scala, a bit of the context. Hopefully, by the end of this, you'll at least have a good idea where it hurts, where it's easy, what you can do to make it an easier transition if you're heading that way. And we should have quite a bit of time for questions because it's normally designed to include about a 15 to 20 minute segment on what Scala is, but you've already seen that today. So let's start with the hors d'oeuvres, assuming I'm pronouncing the word right. New Brand Analytics, which is the startup in question, formed its R&D department about midway through 2011. So that's about 2 years ago. We were a startup company, limited budget. We were making revenue, but we weren't profitable at that point. We were cloud hosted, by which I mean we're using virtual private servers on top of Rackspace managed cloud, if that means anything to anyone. We had a very large, complex proof of concept grade code base that was actually serving paying customers at that point. So it was written in Java. It was, as I mentioned, fairly big. We're talking about somewhere in the vicinity of, there's a graph later, so don't take my word for it, but I think about 90,000 lines of Java code. It wasn't huge, but it was a fairly substantial project. And at that point, the company was already in business. They were using a third-party outsourcing company to actually build the prototype of the product, the first iteration of the product. And at some point, the powers that be, the American management of the company, had figured out that in order to scale the business, they need to scale the product, they need to scale the engineering, and for various reasons decided to set up R&D in Israel. So that's where we come in, we being the Israeli R&D team, and that's where my story begins. There are 4 essential strategies when you're faced with a large existing project regarding how to evolve it. Okay, there's really 4 things you can do. You can either evolve the code base naturally, that is take the same code base that you started off with, actually work on it, extend it, add classes, improve, refactor, extend, yada, yada, yada. You can refactor the code base and extend it, by which I mean you can not only start off with the same code base and reuse the architecture, but actually break it down into component pieces and start re-architecting the code base from the ground up, slowly, carefully in production. You can supplant with new architecture, by which I mean you can actually have a different set of services, like a different architecture in place that communicates with the existing architecture at a very low level. For instance, one of the things you can do is you can set up a completely different code base that only interoperates with the existing one on top of the database, on top of actual business entities that are stored. That's a fairly common way of doing that. Or you could have a complete rewrite of the system, by which I mean you freeze development, you don't do anything with the pre-existing code base, and you actually, go to a room, shut the door, come out after a couple of years with something that likely isn't functional after your company has already gone bankrupt. So these are really the 4 basic strategies. Now, what we had, a bit of context before I come back to this, is complete system rewrite is completely impractical for a company of New Brand Analytics. As I mentioned before, we actually had paying customers at that point. We had to maintain business continuity. We couldn't just stop servicing existing customers. More importantly, we couldn't freeze the system as is. I mean, even if it could continue to serve existing customers as it was at that point, these existing customers would not be retained. We'd lose them within a few months if we had not exhibited actual progress on the product. You know, improved performance, added features, improved the interface, all that stuff. If we did nothing, we'd lose our customers. And we couldn't have that because, as I mentioned, a company that produces revenue but is not profitable. That means it has a limited lifeline that's determined by how much money it has in the bank versus how much expenditure it has, like how much it spends on R&D. And you know, it balances out just a tiny bit with the revenue that we were making at that point, far from being profitable. The team, another important factoid, the team that we're structuring at the time, we started off with, I think, 3 or 4 team members in Israel, and we eventually grew to about 25. I was the 3rd or 4th employee in Israel, I think. And at that point, we made the decision to hop to Scala. So at that point, we're a small team. We were, all of us, very comfortable with the Java platform, by which I mean the language, the tool chain, the JVM itself, the ecosystem, libraries, all that stuff we're really, really comfortable with. But each and every one of us hated the language and wanted a better Java. Okay, that's in a very broad nutshell what brought us to Scala in the first place. So coming back to the strategies, evolving the code base was a big no-no for us. It was crap, okay? I mean, I'm being very, very aggressive about this. It wasn't objectively crap, but it would have been a hell of a lot of work for us to actually use the same code base, the same architecture. For instance, just to give you a bit of a taste what we're facing at that point, the existing architecture had a complete ORM system implemented in Java that didn't look anything like any standard ORM system that you've ever used. Or, for that matter, it was a much higher abstraction than just just DAO classes that actually use JDBC. A much higher abstraction than that, much lower than Hibernate. So it was kind of a mishmash that made no sense. There was no business rationale for it being that way, so it just made our lives way harder. So that was a big no-no. You can cross that right off. I'm going to skip this because we ended up doing the refactor and extend option, but let me explain why supplanting with new architecture was not an option. Complete rewrite, already discussed, business continuity, would have died. We could not supplant with new architecture because the existing architecture was extremely tightly coupled to the database, the data structure, and the data model. And the data model did not necessarily make sense. Basically, any feature that we'd have wanted to add and maintain interoperability with the existing code base would have required us to go through the motions of figuring out how the ORM layer in the existing architecture works, which defeats the purpose of the exercise. We didn't want to do that. It was painful. So if we were to add side by side, have a new architecture going on, we'd still have to figure that out, which was horrible. So what we ended up doing was refactor and extend. Okay, we basically started off with that code base. As we evolved our understanding of the code base, our understanding of the business domain and the business requirements and the technical requirements of the system, we would opportunistically take down bits and pieces of the system, break them down, write tests where plausible, just figure it out and rewrite it were it not possible for relatively small bits and pieces of the system, and piecemeal, we replaced it. Which brings us to Scala. Scala is a JVM-targeted, statically typed language. Okay, it's syntactically quite similar to Java with a few glaring differences, like using square brackets instead of angular brackets, and having type definitions after their names, after the symbol naming. But it is fairly close to Java in syntax. It has quite a few success stories. Twitter use it very heavily. LinkedIn do too. Foursquare, Meetup, quite a few other companies. So even at that point, all of this was true 2 years ago. Okay, Foursquare was actually fairly new to Scala at that point, but still there have been enough success stories for us to convince ourselves that, okay, we're not alone in this. We're not just throwing our weight behind an unproven, newish, bleeding-edge technology that no one knows and no one uses and might be dead in a couple of years. It was pretty obvious at that point that there's a future in it. There's an active community, a very active community actually around Scala. I'm going to go back to this in regards to tooling and libraries and all that, but suffice to say that there's a lot of activity around Stack Overflow for Scala. There's a very active, very buzzing ecosystem for libraries and tools. So it was kind of a safety net. You know, we're looking at that language. It was new to us. We knew it had a lot of rough edges. We needed to know that there's people we can talk to. Even if they don't have the answers, there's at least people we can consult who have some of the shared pain. You know, we can swap stories with them. We can swap ideas. We can swap code samples. So that was very important to us at that time. The tool ecosystem at that time was, actually at that time it was mediocre at best, by which I mean you could use pretty much the same Java tools. I'll get back to that point later, but you can use pretty much every Java tool with a Scala project, but it's not convenient. The IDEs a couple of years ago were horrible. They were unstable. They were really not robust. We were willing to live with that. We're a small team. We knew it was getting better. We could have lived with that. Nowadays, the situation is completely different. The tool ecosystem, while not up to Java standards, I mean, the tools are not as mature, not as fast, not as complete as the Java-based tools. The tool ecosystem is actually pretty good. Okay, you can get at least 2 different major IDEs that really work. You can get several build systems. You can get a lot of libraries. You can get debuggers. You know, you can get quite a few things that work well with Scala nowadays. And this is a contested point, but as far as we were concerned, the learning curve for Scala was reasonable. That is to say, Scala is kind of like Tetris. You know, it takes a couple hours to figure out and start working with, a couple weeks to get, well, depending on the company, depending on the team, on the project, et cetera, it could take a few weeks to get productive in and a lifetime to master because it's complex. Alternatives. We were looking at JVM-based alternatives. As I said, we were all comfortable with JVM. We didn't want to move off of the JVM. So cross Ruby or Python or, you know, pretty much any other language that's not JVM targeted off your list. We could have used JRuby, Jython. I'm not even going to go there. But yeah.
Why is JVM so important to stay on the JVM?
Well, the original code base was in Java, so that's one thing. We had to interoperate with it, and we had to be able to extend it. We were all comfortable with the Java platform. As I said, we're a small team, pretty small at that point, say 4 developers, and each of us had years of experience with Java and the Java platform. On Linux, you know, we had this thing pretty much down to an art form at that point. We just wanted a better language for it. So the platform I'm still comfortable with. The language choice becomes very important in that sort of project. So we took a serious look at Clojure. There's 2 problems with Clojure. The first is it's a dynamic language, and we as a team had a distinct preference for statically typed languages. Strictly a preference. I'm not going to go into the philosophical debate. My preference is for statically typed languages. Yeah. Oh, I thought. Yeah. Sorry. So that's one disadvantage that Clojure had over Scala. Second, the Lisp dialect. Okay, I took a couple of days. I took a look at a lot of Clojure-based code, and my pinky finger started aching from the expectation of hitting the shift button so many times just for the parents that, you know, just from reading the code. So I'm not a big fan of Lisp syntax. Again, an aesthetic preference. I'm not saying that it sucks. I'm just saying that I don't like it. So Clojure was crossed off the list. Groovy also has the disadvantage of being dynamic, but the major advantage of being way closer to Java than pretty much any of the other serious alternatives out there. The problem with Groovy, other than being dynamic, is that it's a very neat language, but there are no major success stories of it. Like, I don't know of anyone seriously using Groovy to build large-scale production systems. There's build systems, there's scripts, tools, there's a lot of stuff built in Groovy, There's Grails, which, once again, I don't know anyone who uses Grails at a serious large-scale production system. So I guess you could say that it was a bit scary. You probably could, it would probably work, being the JVM, it would probably work at a reasonable scale and all that jazz. But we just looked at it and said, okay, no one uses it. That's, that's that's kind of an alarm signal for us. Kotlin, which is the freshly new JetBrains language that isn't even out there at this point, not in production form, is actually the closest serious competitor that I've seen so far in the landscape to Scala. It's statically typed. It has a syntax that's very similar to Java. It has a lot of the same baseline improvements over Java that Scala has. It has a much less complex, much less powerful type system than Scala, but it looks to be powerful enough, arguably. But especially 2 years ago, but I think even today, it's in its infancy. Okay, it's a language that looks to be promising. I don't know if it's ever going to catch on. I think it's going to give, if it does catch on, it's going to give Scala a run for its money. Having said that, I still prefer Scala because it's that much more powerful, but it's just strictly not an option at the moment. You're going to have to live really on the bleeding edge in order to work with Kotlin. Let's head on to how we made a transition and what we learned. Questions so far?
Just one question.
Yeah.
Do you consider transforming also the web application or the container, or only the code, the implementation of the app itself?
So the question was, have we considered replacing also the web application, the web container, to a Scala-based platform? So the answer is Scala runs also, not just, but also on the same platforms that you know. Like, you can produce WARs, you can run on Tomcat, you can run on Jetty, you can do all those things with Scala the same as you do with Java. Scala does add quite a few frameworks or quite a few idioms that you can use, like Play Framework, which runs off of Netty. It doesn't do servlets anywhere in its pipeline. We haven't done that because we had no need to. So it would have been a major restructuring. We actually built an entirely new web application that was built off of, the backend was built off of Scalatra, which I'll touch again when we come to libraries. But it wouldn't necessarily have made sense to actually migrate just for the sake of migrating. Any other questions up till now? Cool, moving on. So, caveat emptor, okay? Let the buyer beware. If you're going to be working with Scala, there are a few points you should be aware of. First off, it's bleeding edge. It's not nearly as bleeding, nor nearly as on the edge as it was a couple of years back when we started, but it still is fairly bleeding edge. If you're going to be working with Scala, you're going to be in the minority today, in the industry, especially in Israel. Okay, in Israel, there's a number of companies that work with Scala. The whole point of Scalapino is to actually, make sure that you have people to talk to if you're seriously considering or are transitioning to Scala. But there are rough edges. You will get cut. Certain things that you expect to work completely and absolutely and in a performant manner and with few or no bugs out of the box are not going to work like that because it's a newish language. Scala's been around for 6 to 7 years. It's been actively used in production for 3.5 years, give or take, by any sort of major contender. It's gone a long way towards stability. They've sorted out a lot of issues with performance and stability, and backwards compatibility is improved radically. The new releases are a lot closer to backwards compatible than they used to be, but there are rough edges and you will get cut. So, if you're expecting a seamless experience the way that you've used Java or C# to this day, you're expecting the wrong thing. You're not going to get it. Okay, you will have to deal with some ickiness. There is a learning curve to it. Okay, it takes a while to figure out the syntax. You could hypothetically start writing code in Scala from Java after 2 to 3 days. It'll take you probably 2 to 4 weeks to actually get to the point where you're comfortable enough with it to actually write production code, and it's going to take you quite a few months to get to the point where you feel that you've mastered the basics and you're ready to move on to higher abstractions, to more powerful type system features, to Scala Z in the sense that Shimi presented in his presentation just not 2 hours ago. Okay, it takes a while to mature up to that point. Rough edges, as I mentioned, occasional compilation errors, tools that don't work as reliably as you're used to in the Java world. Those are things that you're gonna end up running into. And this is not as big a problem as it was a couple of years ago, but partial outdated documentation used to be a problem. Nowadays, the API documentation for Scala is actually top-notch. But if you're doing a Google search for something to do with Scala, you're very liable to run into blog posts from 2 years back that are not only no longer relevant, but are actually misleading, because a lot of the things that were said be it as criticism or as solutions to various issues with Scala 2 years ago, are actually no longer true today. So that's an issue. Okay, it's an issue that will resolve itself in time, but you can't expect it. The bottom line is, was it worth it? Hell yes. It takes a bit of preparation to smooth out the rough edges, but it's way worth it. So I'm gonna mention that over and over again, probably over the next, 25 minutes, I think. So focal points. Here's what we're gonna be seriously talking about: the learning curve, tooling, and running Scala in production. Those are lessons learned. So regarding the learning curve, that's probably the biggest hindrance to Scala adoption in the enterprise. Okay, 99% of you, when you're gonna come to your CTO or VP R&D and tell the guy or the woman, as the case may be, we want to be using Scala in our code base, the first question you're going to be asked is why, which is arguably fairly easy to answer. The second question is, what are the risks? So the risks include, in terms of learning curve of the actual language and ecosystem, functional constructs need getting used to. Okay, the way that you write code in Scala is, in my opinion, actually significantly superior in every way to imperative programming in C# or Java, whatever. C# crossed a lot of that gap with LINQ and with extensions to the collection library. But the way you write code in Scala tends to be more in terms of declarative programming. Like if you say have a list and you want to filter only the odd numbers, whereas in Java, what you would do would be imperatively to create a target collection, iterate the source collection, do an if on each element. If it matches the predicate, then add it to the target collection and return the target collection. That's an imperative way of thinking about the problem. You're thinking in terms of how, not in terms of what. What you actually want to do is you want to say, I have this list of numbers here. I want to filter it through a predicate that says, is this an odd or even number? And every even number I want to just throw out, and out of this whole thing, I have this one expression that says, given a list, I filter out all the even numbers. That describes the what, that describes the intent better. So it takes some getting used to, okay? Especially the functional constructs like there's the trivial ones like map and filter, but there's also not quite so trivial ones like zip, okay? A lot of early first-time functional programming practitioners have a huge issue getting the hang of the zip operation, and I can't blame them. It takes a bit of a paradigm shift in the way you think about writing code. So, a few best practices. One more risk before I get to how to deal with these risks. Coding conventions. There are a few best practices, few commonly accepted best practices. Like with Java, pretty much every company has its own style guide for Java. A lot of them look alike, but it doesn't matter. Okay, everyone knows how to write Java code in a nutshell. Typically, not necessarily, but typically you have the opening curly brace on the same line, and you indent these types of expressions, and you know not to do more than 4 or 5 degrees of nesting because it looks like a mess on the screen. All these kind of best practices, all these conventions are learned behavior over what is it now? I think 18 years of Java programming. And before that, because Java looks a lot like C, about 20 more years of C. Okay, so it took a long time for these, commonly accepted truths to kind of surface out of a lot of code being written in the target language. Scala hadn't been around that long, so you don't have that body of knowledge. You have people, you have opinions, okay, but you don't have widely accepted best practices. So that's one thing. Then you have patterns, like how do you do a thing? Is there a common pattern? In Java, when you want to write a singleton, everyone knows how to do that. Or you Google it and you get 15 answers that all look the same because it's a pattern. Okay, once again, learned behavior. 15 years of history, 18 years of history for Java. Everyone knows how to do stuff in Java. Everyone knows how to write a singleton. Everyone knows how to write a runnable. It's common sense. You don't have to think about it too much. In Scala, there are very few well-accepted patterns, which means that whenever you run into a challenge, you have 5 to 10 different ways of solving it, and all are equally functional, like all work. Some of them, it becomes very obvious very quickly whether or not they're good or bad ideas, but even then you're still left with 3 different ways of doing something that are all seemingly equally valid. So which do you choose? The third risk is dangerous features. Okay, as with every new programming language, especially one that has a distinct experimental bent, Scala has some features that should be considered dangerous features you'd want to avoid. Hey, you wouldn't want to use path-dependent types because it's not likely that you understand them as well as you think you do. It's not likely that you'd want to use variance prefixes on your type parameters because it's not likely that you need to, and it's not likely that you fully understand what you're doing, and you may run into heaps of trouble later. So these are also fairly misunderstood. Like, there's no guide that says don't do this, don't do that. I have my own guide. It's an opinion. It's not a commonly accepted best practice. So, mitigations. What do you do about risks? One thing is that Scala is a relatively familiar syntax. It looks enough like Java, enough like C# that most programmers, when they run into Scala code that's well written, that's not, inherently over clever, what we call in Hebrew over chochem, betachnet nudnik. Okay, when you run into code that's properly written as a Java developer, it's usually fairly simple to understand the intent, to understand what it does. Not necessarily how sometimes you run into clever code that's intentionally clever, and because it takes cleverness to solve a certain challenge, and then it may take you a while to figure it out. But generally speaking, it's fairly readable. It's familiar enough. If as a Java developer who had never touched more, shall we say, esoteric programming languages, I'd go on to read Clojure code or Haskell code, my brain would explode, which is not fun. So relatively familiar syntax means that the learning curve is a bit more sustainable. Seamless Java integration, that's one of the big selling points of Scala. Scala is Java. Okay, it compiles to Java bytecode, class files, jar files. Everything that you know from the Java world is there. There's no magic, there are no surprises. It's bytecode. Okay, that means that you can evolve your code base to include Scala on an incremental basis. You don't have to make the decision to switch to Scala, and from this point on, we need to start converting our code base, and it takes half a year just to get to the point that we started off in. You can do this incrementally, and you can not necessarily avoid the risk, but you can manage the risk of introducing Scala to your code base. You can reuse existing components, existing libraries. You can reuse the same com.yourcompany.util Uber package that you have that includes like 30 different helpers and all that stuff that you're familiar with that helps you code. You can reuse that. You can use the same libraries that you're familiar with, Joda, Spring, whatever. Once again, I'll get back to that in a minute. And one kind of mitigation factor that it has, one thing that makes this whole thing easier to swallow and smoother to go through this transition, is that Scala has a lot of wow moments. Okay, as you transition to Scala, each and every one of your engineers is bound to have at least 5 to 10 10 instances where they just stop whatever it is that they're doing and says, I didn't know I could do that. Shit, that's awesome. Okay, that happens a lot when you transition to Scala because it's more powerful, because it's more concise, it's more aesthetically pleasing, if you will. Okay, it's an engineer's language. It's fun to use. A major lesson that we've learned is that we need to have a cultural recognition that we want to move to Scala, and it takes effort and resources. Okay, that's something that you simply cannot avoid. So 3 things that you ought to do is you ought to encourage experimentation. You ought to encourage your developers to waste time trying new shit out. Okay, they're gonna need the time, they're gonna need the managerial acceptance that they're gonna be wasting time testing stuff. You know, here's a feature. I wonder if it would work for us, what it does. I wonder if I can use it. I wonder if this is clever or unreadable. They're gonna need the time to experiment, and you're gonna have wasted time during the transition, and that's fine. Okay?
It's not wasted, it's invested.
Semantics. Semantics are important, I'd agree. But the point is that a lot of time, one of the foreseeable risks, like one of the things that are most common to people who are scared of moving to Scala is exactly that. What I'm saying is, instead of being scared of it, embrace it. Just make it part of your routine. You know, realize that you're gonna have reduced productivity for a certain amount of time as you learn the new technology. It's not gonna be years, it's gonna be, even if it's gonna be months and not weeks, it's gonna be 2 months, not 6 months. Okay, it's not gonna endanger your company unless your company is already in a dangerous position. Okay, just give it the managerial attention and managerial yeah, I guess managerial support that it needs for to actually work. The second thing is encourage rapid iteration. As a corollary to the first one, encourage your developers to actually take their code, rewrite it, and throw the old code away. Because as you transition to Scala, and because there are few best practices, you're gonna do a lot of really unintelligent things as you go through the transition. You're gonna use dangerous features, you're gonna use features that you don't fully understand, and it's unavoidable, okay? You're gonna fuck up. So take that code, throw it away, rewrite it, do it properly the second time, and understand as managers that it needs time investment, it needs resources, and you're gonna have to redo certain things again and again over the transition. And that also is fine. The third thing is that encourage your team to share knowledge, not in the classic enterprisey sense, okay? Don't have a Confluence space for Scala knowledge, because that doesn't work, but do encourage your developers to, as they pick up new techniques, as they pick up cool things that you can do with the language, as they pick up blog posts that they've read that are really, really useful to them, to document it, to share these techniques, to send an email to the entire R&D group and says, hey, look at this cool thing that I found. This looks awesome. I don't know if it's useful for us. I don't know if I'd ever do this in production, but it's awesome. Because that's the way you learn. That's the way your engineers teach each other. So these are 3 things you really ought to be doing. Get a good grasp of the basics. Okay, Scala has a very, very advanced type system and has a lot of highly advanced features, a lot of stuff you can do with it. There are some really rudimentary features that, in my opinion, are sorely missing in Java. Some of these are actually going to make their way into Java 8, but currently they're really sorely missing. And these are, as I said below, each of these is incredibly powerful. Each of these in itself is a huge improvement in productivity and code safety and joyfulness of your developers. Together, they make ponies, okay? Together, you're gonna be able, together with just these 4 basic Scala features, which are 4 out of, dozens of features that Scala has over Java. With these, you're gonna improve your productivity, code safety, and your engineers are gonna be way happier in their day-to-day work than ever before. So these are functions and closures. This is really basic stuff because you're gonna be using it all over the place, especially when you work with the collection framework. Option wrappers, option wrappers are an incredibly simple construct in Scala that simply removes the necessity for null checks. Okay, if you're going to be using options instead of nulls, it's going to force you to be explicit in certain places that, in my opinion, you ought to be explicit, and you're not likely to ever run into a null pointer exception again. The last null pointer exception I've seen in production was almost 2 years ago. So really simple, really useful. Pattern matching, an incredible feature, and traits, which are basically interfaces with optional partial implementation, which it basically allows multiple inheritance. Like one of the annoying things in Java is that if you have an interface and each implementation of that interface is going to look almost the same up to a couple of methods, then the pattern that you use is you have the interface, you have an abstract class that implements those, everything but those two methods, and then you have implementations that derive from that abstract class. Now, what happens if you want to use, what happens if you want to have a class that has that same basic behavior, adds a couple of other methods, but also implements, something completely different, also implements another interface that has a basic abstract implementation to it. Now, what you do in Java is you delegate. Okay, you have the abstract logic class, which has two fields, one of which is abstract behavior 1, and the other is abstract behavior 2, and you start wiring these things together, and it's just, it's just not fun. So traits let you, in a type-safe manner, have an interface and partial implementation. You can just say, I have these 4 methods. Out of these 4, these 2 are actually abstract. Okay, whomever inherits my trait has to define them, and these 2 are, they have a default behavior that's defined in line with the interface declaration. So that's an amazingly useful feature. And as I said, each of these is immensely powerful. Together, they make ponies. Okay, so if you invest the time to learn these features, these are really, really basic features. You pick them up in days at most when you start working with Scala. As soon as you get a good grasp of them, your productivity shoots through the roof on a daily basis. Another lesson learned, avoid wacky syntax. If you've heard Shimi's Scala Z lecture from a couple hours ago, he had some pretty wild operators at work there, like the Macaulay-Culkin operator, which is pipe at pipe. Okay, what in the hell is that? I have no idea. Now this bit of code here that I don't know if you can see, but if you can't, don't bother because you're not gonna figure it out. Okay, this is a copy-pasted bit of code from the Scala Z examples page. Okay, it's completely opaque. I have no idea what it does, I have no idea what it means, and I have no desire to learn because it's so screwy. So don't use screwy syntax, okay? Name your methods. Don't do quirky operators just because you can, because it looks like crap and the people who are coming after you. The old adage about writing your code as if an axe murderer is gonna be maintaining it after you and he knows where you live. So it works that way. Don't do it, okay? Just don't do quirky syntax. Don't use Scala Z in my opinion, but that's, as I said, my opinion. Shimi has another one. Keep it simple. Another old adage is that the 2 hardest things in computer science, or the 3 hardest things in computer science are naming and off by 1 errors. I think that's the way it goes. So naming is an issue in Scala, the same as any other language. Name your stuff. Name your interfaces, name your traits, name your methods, name your variables, name your parameters. Okay, invest the time to give things the proper name. You won't end up with code that looks like this. And Scala makes it really easy to write code that looks like this because in certain cases, as with a JSON builder DSL, for instance, it's convenient to be able to define syntax like this. But 99% of the time, this is crap. Don't do it. Don't get to the point where you have this code.
I have a question.
Yeah.
How do you enforce this? I mean, I really
culture.
agree with you.
How do you enforce non-crappy code in Java? Code reviews, pair programming, unit tests. That person running around the corridors kicking the crap out of coders for writing crappy code. It's the same, it's culture.
One way is using logic lots of tools that do.
Yeah, you can use linters. You can use, if you're a .NET guy, you can use FXCOP. You can use the equivalent of in Java. Static analysis tools that have certain matchers and check heuristics on your code. That doesn't work, in my opinion. It doesn't scale. So there are static analysis tools for Scala. I couldn't tell you how well they work because I would never use them. Not for that purpose. That's about culture. Promote functional constructs, okay? As with the corollary to what I mentioned before, that functional constructs are kind of hard to learn at times, the reason why you'd want to invest in that is because functional constructs promote intent over implementation. As with the example with the filtering of even numbers that I mentioned before, that in Java would be 4 lines of code and in Scala would be 6 tokens. Okay, a single line, and it's half the size of each of the Java lines of code. It's not because Scala is awesome. It's because it allows you to have a functional style syntax, which in turn it brings intent, it projects intent way better than imperative style code, especially for using the collection framework. So that's really, in my opinion, the most important takeaway here. But also, it saves a lot of code. Okay, I type fairly fast, so I'm not worried about writing an extra line or two. I'd prefer not to have to if I didn't have to, but I don't mind writing code. That's not what Scala is about. It saves you a lot of code because it saves you a lot of, not just because it saves you a lot of boilerplate, but also because it saves you a lot of accidental code bloat. Okay, when you filter a list of numbers and it takes you 4 lines, instead of just saying list of numbers, filter by, and some syntax that says, every element modulo 2 equals 0, that's accidental bloat. It's not because Scala is awesome, it's because Java is ancient. And it doesn't give you the power to have less bloaty code. But another major feature here is that it really supports and it really encourages correct immutable code by design. Okay, when what you write is what you mean, it's a lot harder to have accidents. Okay, in 4 lines of Java code that filters a list by even numbers, it's really easy to have a mistake. If you have a for loop that runs by an index, you may have started 0 based where you should have started 1 based. You may have the wrong condition on it. That's just a really simple bit of code. So promoting intent means that you promote immutability and correct code by design. And immutability, as you know, is really good for concurrency in the broad strokes. Mentor junior developers, that's something you're gonna have to do. If you're gonna be transitioning to Scala, you're gonna need a core team of senior developers that know their shit to study the language, to start using it within the company, and to seriously work with other developers to bring that in. And it's not a big deal, okay? In a team of 10, you only need 1 or 2 of these. They're gonna teach 2 or 3 others, they're gonna teach the rest. In a team of 50, you're only gonna need 3 of these. You're only going to need 3 of these, and they're going to teach 10 others, and they're going to teach the rest of the 50. But you're going to need to start with a seed group of people who are really engaged and really want this, and are really willing to teach others for this to be effective. The other way of doing this is to go out to a consulting company and hire or lease a trainer. Get someone to come in and give workshops and lectures, et cetera. Because that's getting to be available, but we have on the outside, we have flyers for what I perceive as the first major Scala workshop in Israel, commercial Scala workshop in Israel. So it's getting to the point where it can actually do that, but it's still fairly small scale, and you're gonna need your own people to be really engaged in order for the transition to actually work. These are just a couple of small tips. Don't use path-dependent types. That's a dangerous feature, as I mentioned before. Use implicit sparingly because they're hard to reason about at times. Do use them, but don't go overboard. And avoid tuple overload, by which I mean this thing means that I got a tuple of tuples and compared it to a tuple and multiplicated it by a tuple, multiplied by a tuple, and it gets creepy. You know, you extract the first of the pair and then the second of the pair, and you have underscores everywhere, and it's really, really hard to read. So avoid that syntax. There are two things you can do to avoid that. You can either use pattern matching. You can literally give names to each side, to each member of the tuple. You can also you can also use case classes, which are awesome and have really compact syntax. So don't do that. Tooling. I'm going to start running forward because we're running out of time. So there's two major IDEs that support Scala nowadays. Scala IDE, which is a plugin for Eclipse, and the Scala plugin for IntelliJ. My preference is for IntelliJ because I prefer it to Eclipse. I couldn't tell you, my experience with Scala IDE is about 6 months old, and it's improving by the day, so I can only imagine that they're fairly equivalent in feature set and stability and performance. I can tell you that both are fairly complete. The IntelliJ plugin especially is actually complete. You can really work on a large-scale Scala and Java, really, project with it. It mostly just works. Pardon? IntelliJ? No. Well, IntelliJ is a commercial product, but there's the community edition, which is open source, and the Scala plugin is also a community plugin. So you can get the whole thing for free. Personally, I don't mind paying for a really good tool. Like I said, personal preference. So the situation compared to a couple of years ago is way better. Scala support and tools generally, and IDE specifically, mostly just works. There are some caveats. It's not up to Java standards. Okay, you are going to run into occasional performance issues, which is why you shouldn't skimp on dev hardware. Okay, get your developers good machines. SSDs are pretty much mandatory, preferably, you know, quad-core processors. You don't have to go for the absolute fastest in the market. Up until just 3 weeks ago, I've been using a 2 years old Mac 13-inch with a dual-core 2.6 gigahertz PC. It worked fine, but the SSD is mandatory. Without that your developers are going to want to die. In my opinion, it's the same with Java, but you know, for Scala, it's a really mandatory thing. Take your time. Preferably have a go-to guy or gal in your company who knows the stuff fairly well. And by knows the stuff, I mean that's the person who started off, you know, experimenting with Scala, liked it, and went through all the hurdles of setting it up, because it's not as seamless an experience as with Java. So have that person in your company that people can approach for help. As I said, there's an active community. You can always go outside for help. You can always ask questions on Stack Overflow, on Underscore, which is the Israeli Google group. There are people who will help and participate. Okay, in order to get this better, one of the things I'm most proud of having done for the last 2 years is participated really heavily wherever I could and at the scale that I could in the Scala tools. I have dozens of open bugs, well, closed by now, but I have opened dozens of bugs on JetBrains issue tracker, for instance, for the Scala plugin. You know, I joined a whole slew of forums and Google groups, and I've helped where I could. I've filed issues, I've commented on issues, I've tracked commits, I've told the developers when the issue was resolved. I'm proud to have done that because I think I've made a small contribution to the fact that the situation today is so much vastly better than it had been 2 years ago. And I think if more people did that, especially with the open source tools, then it'll just go on improving, asymptotically reaching the situation where we are with Java, where pretty much everything works pretty much all the time. The debugging experience with Scala is still not up to snuff. I know that Scala IDE has some improved Scala debugging support. There's also a Scala debugger, Scala D, which Eugene pointed me to. Eugene is one of our 2 international guests, but I haven't actually experienced yet. The debugging is a bit wonky. I'm gonna leave you with just a couple of tips. Step into synthetic stack frames and do not step over closures. Do those 2 things and you're going to be able to live with the debugger experience. The debuggers, by the way, are the same Java debuggers that you're used to. IntelliJ IDEA debugs Scala just fine and had been since 2 years ago. Eclipse, the same. depending on which debugger you use, they work. Same tools for Java work with Scala because it's just bytecode. Expect the unexpected. You are going to have occasional error analysis issues. You are going to occasionally have spurious errors that are not actually there. Your IDE is going to scream at you when the code is actually fine, or vice versa. And that's annoying, but nowadays it actually generally just works. Okay, the accuracy is improved from 50% of the code 2 years ago to 99 point whatever percent of the code. Nowadays, such issues are actually pretty rare. In a large enough code base, you're going to have one of two of these, but it's fairly easy to work around. And the situation is improving daily. As I mentioned before, the situation nowadays with the tools compared to a year ago is astoundingly better. And compared to 2 years ago, it's worlds better. Okay, there's no comparison. Build tools. So let's talk a bit about actual tools. So the native Scala build tool is called SBT, or Simple Build Tool, which is anything but. Okay, it's a very contested bit of tooling, in my opinion. I don't personally like it. I actually prefer to use Maven with my Scala projects to SBT, even though it's not native. For various reasons, SBT has a very weird syntax. It's complex. It's not very well documented. Even though it's used in a lot of Scala projects, I just prefer to stay away from it. It does, however, use Maven repositories, so you're not going to have a significant change in terms of deployment, artifactory management, all that stuff. If you use Nexus Artifactory, it doesn't matter. It's going to work. And as I mentioned before, it's really, really powerful, but it has an incredibly steep learning curve. It's hard to use. I don't personally like it. But a lot of Scala projects do use it. It has a very, very loyal, very vocal user community. So, up to you. Stay away from Ant. That goes without saying for Java as well, but stay the hell away from it for Scala projects. It's going to be a world of pain. Maven works just fine. There's a Scala plugin for Maven, which you just add to your build plugins settings, and you don't really have to worry about anything beyond that. And Builder and Gradle also reportedly work, even though I don't have any personal experience with them. Compiler nasties. So it's not Java-C, okay? It's a different compiler. It has different edge cases, which you may run into. If you run into really, really scary typer errors from the Scala compiler, know that you're using Scala 2.10 and know that you're not likely using the latest version of it. The first version of Scala 2.10, which is the latest major release of Scala, actually had quite a few edge cases in the compiler where you'd get really, really creepy errors. Nowadays, it's not nearly an issue. Okay, with the latest minor release, 2.10.2, which came out, I think, about 2 months ago, I think, it's really no longer an issue. You're not going to get scary compilation errors. You might, okay? You might get scary compilation errors, but they're actively worked on, and like I mentioned, most have workarounds, and there's a community you can ask. And you can participate in the type-safe issue tracking, which is pretty much the most I can and would expect from you. Slow compilation, okay? One of the actually meaningful criticisms of Scala is about compilation time. Scala is a complex language. The type system is complex. Consequently, the compiler is complex, and it's way slower than the Java compiler. Okay, get used to it. There's no working around that. I'm not gonna sugarcoat it. The compiler is way slower than with Java. Is it something that you can't live with? In my opinion, having worked on at least 3 different pretty large scale projects with Scala, you can live with it. Incremental compilation, SBT has an incremental compiler that's since been forked off into separate projects and is actually included in the Maven plugin and in IntelliJ. Okay, it helps a lot, the incremental compiler, and it will improve. It improves. It has improved. It will improve, but it's something you should expect. The compilation is way slower. That's a fact. Library ecosystem. There's a fairly large, fairly mature landscape of libraries for Scala. Actually, a lot more than you might expect from a language that's this young. For testing, instead of JUnit, use either Spex2 or Scala Test. Both are extremely full-featured, extremely mature testing frameworks. Between those three projects, I have thousands of tests written on them. It's way more, the code itself, okay, the test code is way better than it would have been with JUnit or any of its contemporary siblings. Okay, testing with Scala is awesome. It's the best testing experience outside of a dynamic language you're ever likely to get. Well, up until someone pops out an even better language. Relational mappers, yes, you can use Hibernate. No, you shouldn't use Hibernate. Okay, if you want to use a database abstraction library, then there's two major options with Scala. There's Slick, which you know, if you've been around, then you saw Stefan's presentation on Slick. I've used that in production. It works. It's fine. It's pretty awesome. I have my own issues with the query syntax. I don't think something that runs against the database should look like Scala code, but that's my opinion. Which brings us to Squirrel, which is the other side of the equation. Both are full-featured type-safe ORMs. Both work very well in production. We have pretty heavy systems running on both, and Squirrel differs from Slick in that it offers a LINQ-style SQL-like syntax for querying. In my opinion, it's preferable. Web frameworks are actually where Scala really, really shines. Well, concurrency is where Scala really shines, but web frameworks in Scala actually are extremely mature and extremely powerful. There's three flavors depending on what you're looking for. The Play framework is a really full-featured web framework that's in many ways comparable to Rails. Okay, it has convention over configuration down cold. It has a lot of features. It does a lot of things. It's very pervasive.
We're starting the gym talk in the next room.
Yeah, so I need to finish like now.
To finish like 10 minutes.
Well, I didn't have anyone to thing me except that, and
So,
I guess I started late.
You delayed it for 5 minutes?
5 minutes would be awesome if it's possible. If not, then not.
Delay for 5 minutes.
Okay, so we have an extra 5 minutes. I'm gonna run over this. These are awesome. These are awesome. Everything on this page is extremely usable. It's a matter of flavor which you should choose, if at all. All of these work really, really well in practice, in production. Finagle is Twitter's concurrency framework, so you can imagine the scale. Akka is used in thousands of projects, is really powerful. Both are really awesome. The point here is that you can use your native Java libraries. You can use Hibernate, Spring, Guyava, whatever the hell you want. It works. Okay, there are very few caveats. I'm not going to cover them, but it really works. In production, things you ought to know are that Scala works a bit differently. It generates a lot of intermediate, short-lived objects. So that means there are a lot of generated classes. Like each closure, for instance, generates its own inner class. Implicitly for you, you don't have to worry about it, but it does mean that your PermGen is going to be working overtime. So just increase its size. That's usually good enough. There are a lot of intermediate objects that are generated as you go through the functional constructs. So if you run into issues with that, which you don't normally do, you could run into the point where they're just long-lived enough to spill over into the old generation and not short-lived enough to be killed off by the copy collector. You can always tune your GC settings. You're not likely to ever need to do that, but here's one example of how to do that. It emits a lot of synthetic code. That means that on occasion you might run out of stack because the stack depth is a lot higher than you're used to in Java. It's not something that's normally visible to you, but you may need to increase your stack size. And the stack trace itself looks different. You have a lot of synthetic frames, a lot of delegate functions, etc., in between your actual user code. So that takes some getting used to. You learn to filter out the cruft. Same way that you read a Java stack trace and you know to ignore pretty much the bottom third because it's Tomcat code or thread pool code or whatever that you don't care about. It takes a couple weeks and you're used to Scala stack traces. You don't have to worry about it. Also, there's a tool called Stackifier by Takipi, which is an Israeli company who developed development tools for Java and Scala, and it helps figure out Scala stack traces a little easier. It's web-based, really simple to use. It's nice. The dessert course, and I'm gonna stop here. This is the codebase evolution for the new brand analytics codebase. Okay, this is based on Git logs, K lines of code, up to about 180 over weeks of development. As I mentioned before, this whole project, you could say, had been running for just over 2 years. So we have week 1, and we have a couple weeks back, week 124. And you can see that we started off just writing really small amounts of Scala code, experimenting, not doing much. And then we went haywire, stopped writing Java code, deleted half the Java code base, and rewrote way more lines of code in Scala than we lost in Java in the first place. And just as a reminder, Scala code tends to be a lot more condensed, tends to be a lot more concise than Java code. So those something along the lines of 100K lines of code in Scala that we wrote are roughly equivalent, in my opinion, to some, 400,000 lines of code in Java in terms of what they do. So just, it's an arbitrary metric, but it does indicate that we've pretty much at week 13 or 14, okay, that means after less than 3 months, we literally stopped writing Java code and started writing masses of Scala code. So that's one company story of transitioning to Scala. I'm sorry that we don't have any time for questions. Thank you for listening, and have a nice day.